Hi children, hello, welcome to your home school. This is your next session of your class 10 mathematics NCERT CBSE board. So this is your second chapter, triangles. In our last session we have completed up to exercise 2.3 10 problems. Now we are going to start with the 11th problem. Look here. In figure, can you see the figure there? E is a point on side CB, produced of an isosceles triangle ABC with AB equal to AC. If AD perpendicular to BC and EF perpendicular to AC, prove that triangle ABD similar to triangle ECF. So now what is given here in this problem, children? E is a point. Can you see the point E? Yes, E is a point on side CB when CB of an isosceles triangle. So look here children, first observe here, ABC is a triangle which is isosceles set. So look here, this is a isosceles triangle where AB is equal to AC given. And what did they give? If BC is produced, it is going to meet at a point E. E is a point on side CB when produced of an isosceles triangle AB is equal to AC. So now immediately what do you remember? Isosceles word, if you remember, yes, two sides are equal. If two sides are equal, two angles are equal. Do you remember children this is all? So let me draw you here. Look here. ABC is an isosceles triangle where AB is equal to AC given here. If AD perpendicular to BC, AD is perpendicular to BC and EF is perpendicular to AC. Okay. Prove that triangle ABD, observe where is the triangle? This is the triangle ABD and triangle ECF. Okay, just try to observe where I have shaded here. So now first when you remember isosceles triangle, these two sides are equal given. Then I can say the opposite angles are also equal. If two sides of an isosceles triangle are equal, then their opposite angles are equal. So now angle B equal to angle C. So where it is here, angle B is equal to angle C. I'll mark equal. Now what we need to prove here children? We need to prove that triangle ABD is similar to triangle EFC. What is your solution here? Given ABC is an isosceles triangle. And then what they have given? AB is equal to AC and AD is perpendicular to BC. And one more, EF is perpendicular to AC. Okay. So now what we need to prove? To prove triangle ABD is similar to triangle ECF. Okay. Let's start our proof here children. How do we start? Consider triangle ABC. Consider triangle ABC. What did they say here? They have said ABC is an isosceles triangle where AB is equal to AC. Why? They already have given it is an isosceles triangle. If you consider that triangle ABC, AB equal to AC over. Now what I can say here? Angle ABC is equal to angle ACB. Try to understand here. You can just write angle B equal to angle C also you can write. But always in exam shortcuts is not good. Right? So do like this only. So what you can say? We know. Given. And how we have written this statement children? If their sides are equal, their opposite angles are equal. We know that. So now next step. Consider Triangle, what the triangle we need to prove? ABD and triangle ECF. Consider the triangle ABD and triangle ECF. So now what I do here, children, I try to remove the two triangles aside. So now ABD, let's take as it is. Look here. Just I remove the triangle in order to compare and it will be easy. ABD, where D is a right angle and angle B. Okay, let's see later. Another triangle ECF. How can we take ECF? Okay, look here how my fingers will move. This right angle, rotate and keep like this. See here, this right angle, rotate and place like this. Okay, such that. Okay, this is perpendicular, children. Same manner, like this, perpendicular. What is the point here? F, and above E, and this is C. Now, by this figure, what I can say? Angle B is equal to angle C. And the given statement, angle D is equal to angle F. So now, directly I can say by comparing these two triangles, two angles are equal, then by angle-angle similarity criteria, I can say the two triangles are similar. So, once again observe here carefully, children. So, ABD, I have taken this right angle and placed here. Okay. So, right angle this side there. You place another figure in such a way, try to rotate and keep there. So, easy to compare. Now, angle D, angle F. Angle B, angle C by the given data, right? So, now, in triangle ABD, what I can say here? ADB is equal to angle EFC. How, children? It is given. It is already a given data. Next step. What is your next step here? Angle ABC is equal to angle ACB. How we are saying this? This also given. What they have given? Sides given in an isosceles triangle. We have taken according to the statement, if sides are equal, opposite angles are equal. So now, according to that, what can I say? Therefore, triangle ABD is similar to triangle ECF. By what I am saying this? Therefore, by angle similarity criteria, I can say that these two triangles are similar. Yes, let's see the 12th problem, which is very important problem in this chapter. So, let's see here. Side AB and BC. Look over here. AB and BC and median AD. So, median they have said AD, children. So, I have taken vertex A here. So, what is that? Sides AB and BC, median AD, okay, of a triangle ABC are respectively proportional to sides PQ, QR and median PM. So, observe carefully here. So, what is that, children? AB is proportional to PQ and BC is proportional to QR. AD is proportional to PM. What is that? Two sides and a median of one triangle is proportional to two sides and median of another triangle. So, what is your question here? Show that triangle ABC is similar to triangle PQR. But what is the condition given? These two sides and a median, and these two sides median are proportional. So, we need to prove full triangles ABC and triangle PQ are similar. I just want to give you a hint, children, how we are going to do the problem. So, we are going to take side, median, side, median. But I am going to take one triangle separate, children. How? For this side, median makes it equal parts, right? So this D, what does it do? BD is equal to DC. And whereas BD is half of BC. They have given BC ratio equal. But instead of BC, if you equate half of BD and here same manner half of QM, half of cancel, or in the place of BD, you can write half of BC, or in the place of BC, you can write it as 2BD. So we try to bring the ratio in such a way that these two triangles, we will make them similar. Okay, if they are similar, then their corresponding ratios will be proportion and angles will be equal. My target here is to make this angle and this angle equal. If I can make this angle equal, side angle side by SA similarity criteria, I can prove this problem. Okay, let's start a solution here. By the given data in triangle ABC and triangle PQR. Observe here, triangle ABC and triangle PQR. AD and PM are their medians. AD and PM are their medians. And other two sides, what they have given? ABBC, PQ, QR already given in the question. So you can write, or the three ratios directly I have showed here, proportion. What is that ratio? Look here. AB by PQ, BC by QR and AD by PM. So look here, this is the ratio proportion, children. What we need to prove? We need to prove triangle ABC similar to triangle PQR. So what we know? Median equally divides the opposite side. So by this what I can say? BD is equal to DC. Okay. Or BD equal to half of BC I can write. Or DC is equal to half of BC I can write. Or in another way, how can I write this? I can write BC is equal to 2BD. Or DC is equal to, or BC is equal to 2DC also you can write. BD is equal to DC or any one part is half of BC. So now let's compare these two, children. BD is equal to half of BC. Then this dividend, if it goes on the side, multiple, right? Now what can I write? BC is equal to 2BD. Similarly, you change that triangle, children. How can you change that? QM is equal to MR is equal to half of QR. Now compare these two, any two ratios you can take. I just want to take this side triangle, right? So I have taken only QM. So when you compare this two comes this side, that makes QR is equal to 2QM. Okay. Now take the given ratio here. What is that? AB by PQ is equal to BC by QR is equal to AD by PM. Now observe here, children, carefully. In the place of BC, substitute 2BD. In place of QR, 2QM. So now AB by PQ is equal to, what is BC? 2BD. And QR, 2QM is equal to AD by PM. Now look here, this two cancel. Now what the ratios you got? Observe here carefully. AB, PQ. And here BD, QM. AD, PM. Means this two triangles, the corresponding triangles sides are in proportion we got. If these two triangle sides are in proportion, what can I say? The two triangles are similar. If these sides are in proportion, the two triangles are similar. So what I can say here, children? Therefore, triangle ABD is similar to triangle PQM. Okay, these ratios are in proportion. I can say that the two triangles are in similar. If these two triangles are similar, I can say that the corresponding angles are also equal. So if all the ratios of a triangle is similar to another, by which we are proving now side, all the corresponding sides are in proportion. So I can say that these two triangles are similar. If they are similar, what I can say, children, the corresponding angles are equal. So let's equate the corresponding angles. These two angles I don't want. I just want only this angle I want to equate here. Right? That is, equate the corresponding angles. Angle ABC is equal to angle PQM. When the two triangles are similar, then their corresponding angles are equal. According to that, I have taken the two angles are equal. Now, once again, look here, children. When we start comparing this triangle, ABC and triangle PQR. Now, look here, this ratio is proportion and these two ratios are in proportion and this angle is equal. So now consider triangle ABC and triangle PQR. Triangle ABC and triangle PQR. What you can say here? AB is proportional to PQ and BC is proportional to QR. AB by PQ is equal to BC by QR. These two ratios are in proportion. We know already it is given data. And now what we have proved now? Angle ABC is equal to angle PQM. Therefore, the two triangles are similar. Triangle ABC is similar to triangle PQR. How we are saying that two triangles are similar? By SAS similarity criteria. I can say that two triangles are similar. So once again, observe here carefully. What is given? Two sides AB, BC, PQ, QR and median of this triangle AD and PM. So these three are in proportion. If they are proportion, prove that these two triangles are similar is your question. So what did I do here? In your given data, consider all the three ratios you equate. And what we need to prove, the two triangles are similar. Then we start our proof with the median. If D is median, we can say that BD equal to DC. That BD is nothing but half of BC. In the place of BC, we can equate 2BD. And in the place of QR, we can write 2QM. Now take the ratio again. In BC place, substitute this. QR place, substitute this. 2 cancel. Now what the ratios which are in proportion we got? No, that is nothing but the two triangle ratios. If these two triangles are in proportion, so according to what we are saying here, children, according to all sides are in proportion, then I can say that the two triangles are similar. So if they are similar, by what I am saying this? I can say this by SSS similarity criteria. If all sides are in proportion, automatically I can equate the angles, corresponding angles I can equate. So I don't want all the angles, I need only this angle. So I have equated the triangle and then consider the complete triangles. Then say given data, these two ratios are in proportion and this angle is equal. Therefore, by SAS similarity criteria, the two triangles are similar. Okay, see 13 problem here, children. D is a point on the side BC of a triangle ABC. So I have drawn a triangle ABC. On side BC, D is a point given. So once again, D is a point on side BC of a triangle ABC, such that angle ADC means where it is? Here. Angle ADC is equal to angle BAC, full complete angle, and this triangle, this side angle is equal given. So, show that CA square is equal to CB into CD. How can I find this? Okay, let's see here. What given? The two triangles I am going to split here. How can we split? Complete triangle, right? As it is, you do here. ABC. Now, this triangle, bring it to vertex. How can you bring this angle to vertex? So, cut the piece here, lift this D and put it here. So, what happens? D. So, look here, this D plays here and this triangle plays here. Means DAC is the base. Now, compare the two triangles here. Your answer is here. Angle A, angle D, given. Angle C, common. Therefore, what you can say, children? The two triangles are similar by angle similarity criteria. The two triangles are similar. So, now if they are similar, then the ratios are in proportion. Okay, let's start here. Given D is a point on side BC of triangle ABC. Join AD, mark a point D and then join AD. Where you need to write this join, children? Construction part. Okay, what to prove here, children? We need to prove that CA square is equal to CB into CD. Okay, something we need to prove here. What is that? Let's see later. Next, proof. Consider the two triangles. Consider, in given data we need to write one more, no? What is that, children? Angle ADC is equal to angle BAC is given. And to prove you have written, consider triangle ABC and triangle ADC. Now, compare these two triangles and then what do we know, children? ADC. Angle ADC is equal to angle BAC. How we are saying this? By given data, I can say these two angles are equal. And one more I can say, what is that? Angle ACB is equal to angle DCA. How? Common. So, if the corresponding two angles are equal, therefore, I can say that the two triangles are similar. Therefore, triangle ABC is similar to triangle ADC. By what you are saying, children? Angle similarity. Angle similarity criteria. I can say the two triangles are similar. This is not your proof. Still, we need to prove something here. Observe here. AC square it is. CA or AC same. CA square they are asking. Means, imagine CA by CB and one more CA here, CD by CA. Or CB by CA, CA by CD. Means, some ratios, if they will be proportion, we can get this answer. So, please identify the question carefully. Which is repeated here? AC, right? So, in two ratios, you should get AC. So, in the two triangles, observe here, we have an AC here and in this triangle, we have AC here. So, look here carefully. So, which ratios you will compare? This side and this side ratios we will compare. Now, corresponding ratios say, children, if these two are similar, you can equate the ratio. We can take three ratios, but I need only two to prove this. So, what ratios you are going to write? AC by, observe there, DC. And that side, AC is at the bottom, right? So, compare this side, BC by AC. So, look here, children, AC into AC is equal to BC into DC. Okay. So, now what is AC into AC? AC square, that is equal to BC into DC. So, this is your proof. Observe here, CA or AC same. AC square is equal to BC into DC. CB into CD their question. You can rewrite, no problem children. There is no rule that you have to do like this only, like that only. Suppose if you prefer to get like this only, if you feel, you can consider like this. CA by CD is equal to CB by CA. See, both are correct. Don't think that it is wrong. So let me do that also. CA by CD is equal to CB by CA. Now cross multiply. CA into CA, CA square is equal to CB into CD. See, same you got no? Both answers are correct. So some of the children will do like this and feel that something they have done wrong. So any way you can do children, this is the way we do this type of problems. So before doing these type of problems, understanding the problem is very important. What has given, what I need to think, and how can I proceed my problem. These are the three things you should know children. Okay, with this we are going to end our session. In our next session, we are going to complete our exercise 2.3. Thank you all.